Hi, this is Mrs. Ellison, and I am ready to start the second part of the Algebra 1, Chapter 3 practice test video. We finished with 17, so we'll start this one with 18. Number 18 says solve 0.6 plus 4.8x is greater than or equal to negative 0.2 plus 5.2x. So again, toward the end of the last video, I said, can we distribute? There's nothing to distribute, so we move on to the next step. Are there any like terms on either side that we can combine? And in this case, no. So then, do we have variables on both sides? And yes, we do. Let's move them all to the left so we don't have to flip-flop the expression or the sentence later. We'll do that by subtracting 5.2x from both sides. And 4.8 minus 5.2 would be negative 0.4. It's negative 0.4x greater than or equal to negative 0.2. And then all that's left is to solve that two-step inequality that we have here. We can subtract 0.6 from both sides. And we have negative 0.4x is greater than or equal to negative 0.8. And from here, I would divide both sides by negative 0.4. Now remember, when we have an inequality, we have to switch that inequality symbol when we divide by a negative. So x is now less than or equal to, this would be positive 2. Now, none of those answers looks exactly like this, but we know that it's not x is greater than or equal to 2, it's not 0.93, and it's not 4, so we'll have to look closely at B. Is this equivalent to what I have here? And the answer is if you flip-flop the sides of this inequality, that will give you option B. So that is a good answer. Number 19 says solve and graph the compound inequality. And this compound inequality is a set of simple inequalities separated by the word or. So this actually, in my opinion, is one of the easier ones. We can just solve the two inequalities and graph them just on the same number line together. So the one on the left says s plus 3 is less than or equal to negative 5. If we subtract 3 from both sides, we have s is less than or equal to negative 8. The other inequality says 1 plus s is greater than negative 4. And if we subtract 1 from both sides, we end up with s is greater than negative 5. Remember, these were or statements. So this first inequality has negative 8 and an inclusive or equal to bar, so that's going to be a closed dot, and an arrow to the left because it's less. And this one would be an open dot at negative 5, and an arrow off to the right. And that looks like option D. So 19 is D. Number 20, which of the following is a solution of x minus 6 is less than 7 and x minus 5 is greater than or equal to 3? Well, we could simplify these just a little so that they're easier to evaluate. We could add 6 to both sides here, and we have x is less than 13. And we also have this x minus 5 is greater than or equal to 3. We could add 5 to both sides, which gives us x is greater than or equal to 8. And if you look at the structure of this particular compound statement, that means that x is between 8 and 13. Oops. My computer is slowing down for some reason, so that should be a 13. Okay, and it would include 8, but not 13. So 7 is not between 8 and 13. 12 is, 15 is not, and 13 would not be included because we don't have the or equal to bar here. So B is our answer for number 20. Number 21, Denise has 400, oh, I can't read numbers. Denise has 265 stamps in her collection. She wants to collect at least 465 stamps. Write and solve an inequality to determine how many more stamps she must collect to reach her goal. All right, again, here's that at least. That means greater than or equal to 465. All right, so that automatically knocks out C and D. We have 265 that she already has, plus the number that she wants to collect, or that she needs to collect to reach her goal. And we solve this by subtracting 265 from both sides, which leaves us with D is greater than or equal to 200. So that is option B. Number 22 has a couple of different ways that we can look at it. Marco's drama class is performing a play. He wants to buy as many tickets as he can afford. If tickets cost $2.50 each and he has $14.75 to spend, how many tickets can he buy? Well, he can't spend more than $14.75, but he can spend less than or equal to that. And the amount that he spends is going to be represented by 250 times the number of tickets. So to solve this, we're just going to divide by 2.5 on both sides. And that gives us 14.75 divided by 2.5 is 5.9. T is less than or equal to 5.9. So we have to ask, can he buy 6 tickets? We're tempted to round that up to 6, but he doesn't actually have enough money for that. He would need another quarter, I think. So 6 tickets is out. 5 is the most he could buy. So D is our answer there. Number 23 is kind of similar to that one in the way that you handle your answer. What is the greatest possible integer solution of the inequality 4.978x is less than 15.121? And we can see that to solve this, we need to divide both sides by 4.978. And that gives us x is less than, we get the calculator, 15.121 divided by 4.978 is 3.037565 and a bunch of other stuff. Okay, this asks for the greatest possible integer solution. Well, integers are the numbers that you use to count, the 0, 1, 2, 3, 4, and so on, and the negative versions of those. So we need no decimal part, and if this is less than 3 point all this stuff, we can just get rid of all of the stuff. And 3 would be our biggest, our greatest possible integer solution. Number 24, solve the inequality and graph the solutions. Then write them as a compound inequality. This is an absolute value inequality that we've done most recently. And we know that with any absolute value anything, we have to isolate that absolute value before we can start looking for actual solutions. So we need to add 9 to both sides, which gives us absolute value of x minus 10 is less than 8. And we talked in my classes about when you have this absolute value, that means the distance of the stuff inside from 0. And if it's less than, that means it's within. That's between. That's going to be an and compound statement. And our two endpoints then are going to be negative 8 and positive 8. And this x minus 10, whatever it happens to be, will be between those two endpoints because it's inside with the less than symbol here. We'll solve this by adding 10 to all 3 sides of this inequality, giving us 2 is less than x, which is less than 18. And it looks like that's down here at option D. And last we have number 25. Solve the inequality. The absolute value of x minus 14 plus 9 is greater than 8. We need to isolate that absolute value like always, so we subtract 9. And here we have the absolute value of x minus 14 is greater than negative 1. Originally, when we had just equations, we could say that's no solution because an absolute value is never going to equal a negative number. It's always going to be positive. But with an inequality, you have to ask yourself when this is true. With an equation, it's never, but with an inequality, it could actually be true sometimes. Or in this case, it could be true all the time. Anything you plug in for x, it doesn't matter what number you choose, you're going to take the absolute value and the result will be positive, right? So you have a positive number is greater than negative 1. And which positive numbers are greater than 1? The answer to that, that's all of them. So the solution set would be all real numbers. This is always true. So we have all real numbers as our solution. 25 is C. And that concludes the video for the practice test for Chapter 3. And please be sure to ask your teacher if you have any additional questions. Thank you.